All right, guys, this is moving on to 4.2. This is graphing quadratics, but now we're doing what's called standard form, okay? Which is honestly very different than what we did previously, which was vertex form. Vertex form, all the numbers really give you relevant information. In standard form, to be honest, they really don't, okay? So standard form is AX plus BY. Sorry, why did I say Y? Starting over. It's A x squared plus bx plus c. Okay? Now, the only one of these numbers that means anything to you is the c. The c is your y-intercept. Okay? And right now, we're not really even focusing on that, but we can write that in the end. All right? Now, what you want to know here is to graph these things and to find the vertex and all the things we want to, we of course do first need to find the vertex. We're going to find the vertex, put it in the middle of our t-table, and then we'll be able to find the rest of our graph in our calculator just like we did previously. But what you need to know is how to find the vertex. The vertex is created by finding the opposite of b over 2a is your x value, comma, and you plug that back in to find the y value of your vertex. Okay, so let's start this one, and I think that you'll see what I'm saying. So, of course, here in number 2, A is the value 1, which is imaginary right here. B is 2, and C is 1. Okay, so we first need to find the vertex. I will do. Now look up here at the formula. That doesn't mean negative B. That means the opposite of B. So currently B is positive 2. So I'll do the opposite of that, which is negative 2 over 2 times A is 1, which is negative 2 over 2, which of course is negative 1. That means that my vertex is at negative 1 comma something. Okay, now to find that something, you could right now type this into your graphing calculator and just look at the y value in the table when x is 1. We'll do that in a second. I can, however, just solve it by plugging negative 1 in for x. So I'd have parentheses negative 1 squared plus 2 times negative 1 plus 1. That would be 1 minus 2 plus 1, which is 0. So my vertex is at negative 1 comma 0. Okay. My let's keep going. My axis of symmetry is, of course, x equals the x value of my vertex, negative 1. I'm not really worried about x and y-intercept right now, but the y-intercept, like I told you, is the c value. So the y-intercept is at 0 comma 1. Of course, the x value of all y-intercepts is 1. Since my leading coefficient, again, my a value is positive, I know that this parabola is shaped like a U. So my vertex is a min. The domain is always all reals. And since it is shaped like a U, and we can look at the calculator in a second, let's look at the calculator first before we get too much farther so we can talk about the range. Okay, in my calculator, I'll go to my y equals button, and I'll type this in. I've got x squared plus 2x plus 1. And I'll just first start by looking at the graph. You can see there that the vertex is a minimum value. You can tell that it's all the range is all y's that are greater than or equal to that y value of the vertex, which is 0. Okay. Now, when I am over here making my t-table, I'll put my vertex in the middle, negative 1, 0. And I will now go to my calculator and the table in the calculator to find the rest of the points. Okay, so I got second and graph to get my table. There's my vertex, negative 1, 0. Negative 2, negative 3, 0, 1 for my x values. And I've got 4, 1, 1, 4. Again, notice the symmetry there. And I'll plot those points. Negative 1, 0, negative 2, 1, negative 3, 4. Same on the other side, 0, 1, 1, 4. There's the graph right there. Okay, well, let's do one more. And then we can be done with this video and you guys can start your work in class or whatever you want to do. Uh-oh. Now I got to erase all this. Is that how this is going to work? That's not fun. Sorry, just give me a second. I didn't know I'd have to erase all this. Won't take but a second. Okay, so as you can see here with our next one, okay, I'm going to talk while I'm finishing erasing here. We're still in standard form, ax squared plus bx plus c. Okay, my a value is 3 this time, so it is going to be a little taller and skinnier of a problem. Okay, so my vertex again is at the opposite of b over 2a. Here's b. It's -6. The opposite of that is +6 over 2 times a is 3. That's 6 over 6, which of course is equal to 1. That's the x coordinate of my vertex, 1. I'll now plug that back in to find the y value. So I've got 3 times x is 1 squared minus 6 times x again is 1 plus 4. That's 3 minus 6 plus 4, which is also 1. So my vertex is at 1, 1. Now we'll fill in the rest. That means my axis of symmetry is that x equals the x coordinate of the vertex, 1. Again, I have a positive leading coefficient, so I know I'm going to be shaped like a U. When I'm shaped like a U, my the vertex is a min. The domain is always all reals. Again, we can look at the calculator to help with the range here. I'll type these in. Give me 1 second. I'm finishing up making a video real fast. X squared minus 6x plus 4. I'll look at that graph. Okay, you can tell there that again, the vertex is a min. The range is that the y's are all greater than or equal to that y value in the vertex of 1. As I do my t-table over here, I start with the vertex in the middle, 1, 1. I know I'll use 0, -1 below it, and 2, 3 above it. I go now to my calculator to look at the table. And you can see that at 1, the answer is 1. At 0, it's 4. And at -1, it's 13. I'll plot those points, 1, 1, 2, 4, 3, 13, which should be somewhere up here. And then the points on the other side. And you have this tall, skinnier parabola. All right, so be ready to do your work tomorrow in class. I'll see you tomorrow.